What's going on, guys? Welcome back. My name is Brandon and today we're going to be doing some plug welding, so stick around. So what exactly is plug welding and when would you want to use it? Well, it's actually pretty fun. It's not something that you use a lot, but it's information that you can put in your toolbox, and next time you get into a situation where you need it, you'll have some ideas on how to do it. So let's say you have a body panel on a car and you need to attach it, or even a piece of metal to another piece of metal, but you don't want the welds exposed. One of the things you can do is plug welding means that you have a hole and you are going to weld through that hole to join one piece of metal to the next. Then you can grind the weld flush, and then what you end up with is a piece of metal joined onto another piece of metal without any visible weld all the way around it. Another thing that it works really good for is, like, let's say you have a hole that's threaded and you have a bolt or a fastener that is threaded down into it, and that hole ends up getting stripped out. Well, one of the things that you can do, and we're going to do it here today, is we're going to use some backer material. This is just a piece of copper. Is you can put a copper backer behind it, fill this up, re-drill it, and then re-tap it. That's another great way. If you can't expand the hole and go up one size bolt, you can just plug weld it shut and move on from there. So let's do a couple examples and let's get working on it, and we'll talk about a few things as we do it. So for this, guys, I'm going to be using my MIG 205 DS by Yes Welder, and I just wanted to go over a couple things that people have asked me about on some of the settings and how some of these things work. And this can be explained for a lot of other welders, probably similar as well. So for wire, I'm using 30 thousandths. This is self-shielded wire or flux core wire. But the issue or the question that I've received about this welder is that this is what's considered a synergic welder. So you select your wire size and then you select your material thickness, and then the machine will adjust the rest of the parameters for you. But the issue with this, as you can see, I'm over here on gasless wire. The only option that you have with gasless or flux core wire is 35 thousandths. Well, I'm not using 35 thousandths. So what I'm going to have to do is just use it on the gasless and then just adjust it accordingly. So this has 2T and 4T. 4T would be like if you were doing a really long run, you wanted to press the trigger and let off and just keep going. I just weld in 2T mode. Then it has MIG CO2. Well, MIG CO2 is going to be if you're using solid wire running CO2 gas, or a combination of gas mixtures with CO2. I have C25 gas here, so we want to be on MAG. So MAG is metal active gas, and that would be solid wire with C25 gas. And then you've got stick welding mode here, and then toggle it again, it brings you over to lift TIG. Toggle it again, brings you over to gasless. But you can see that you can't select any wire outside of this. Like if I try to select a different wire size, it's not going to allow me to do it. But let's just say, for example, I'm using solid wire with C25 gas. All I'd have to do here is pick my wire size. So generally I use 30 thousandths, but you could go from 23 thousandths to 30 thousandths to 35 thousandths. I would set it, if this was solid wire, I'd set it for 30 thousandths, hit this button right here, and wait for that to illuminate over there. There it is. Then I just toggle this dial. I would set that number in millimeters, and that is the thickness of my material that I'm working with in millimeters. So set the thickness, and it automatically does its own thing. Now it's all set up, and it's set the amperage just based on what that was for 121 amps, 19 volts. I just wanted to go over that with you real quick, but again, we're going to go with gasless. It automatically drops it down into the 35 thousandths wire category. This material right here is 1/8 inch that we're going to be welding on, and 1/8 inch converted to millimeters is 3.175. So we go over here and toggle it to that and call it 3.1. There we go. That'll set it to 146 amps, 18.4 volts. Now that's going to get us really close in the ballpark. Obviously we're not using 35 thousandths wire, but then if we need to adjust this, we can still rotate this dial and go up or down depending on what we need for usage. So I'm going to just go right around 135, a little bit less because we're using a smaller diameter wire, and go from there. This machine also comes with a handy chart that I keep inside the door. It tells about mag, CO2, gasless, all your settings, wire sizes, material thicknesses, lift TIG, stick welding. It tells you on hooking up the polarity, how to get the correct polarity on the front of the machine, and tells you about consumables. It just gives you a whole host of information. One way of remembering polarity on, if you're using solid wire, is it DC electrode positive or DC electrode negative? Well, I always look at it as people have a negative feeling towards flux core wire, so electrode negative if you're using flux core. That's just how I've always remembered it. DC electrode positive for solid wire. People look favorably towards solid wire with gas. Just kind of how it is, kind of the myth. You hear people say, all I have is a flux core welder. That's not a bad thing. But if you've got a flux core welder, it's going to be DC electrode negative. We are using flux core wire right now, so this stinger lead is going to negative and the earth or ground is going to positive. So let's say we want to join a piece of metal to another piece of metal without having any of the welds showing or exposed. This is how you do it. Whenever you're welding, guys, you always want to make sure that you have the tension set properly on your drive rolls so that you can avoid any feeding issues and problems when you're welding. If you want to know how to set it up, I've got a link up above I'll attach to help you guys figure out on setting up the perfect tension so you can avoid a lot of problems when you're wire feed welding. So now that we've got this hole plugged, now we'll just grind it flush. And this is going to leave a nice clean finish with no welds exposed, and the two pieces will be bonded together. And there it is, guys. You can see if I needed it to be invisible, I would need to add a little bit more weld material around here and then grind it. But as it is, you can see there's no visible weld exposed. There's none around the edges. The two pieces are joined together, and this would be an invisible repair or joint or bonding for whatever reason. So another reason for plug welding is, let's say you have a hole in a piece of metal and you don't want a hole in a piece of metal. You want it smooth again. You want it flush and finished looking. Well, one of the things that you can do is get yourself a copper backer or aluminum. Aluminum works good. Copper works well. Clamp the two together and then just fill the hole shut. The reason we use a copper or aluminum backer is that the material, the weld material, won't stick to this. It won't stick to copper or aluminum. So what I'll do, guys, is I will clamp this down onto my fixture table using my fixture clamps that I built onto the fixture table that I built. And if you're new to the channel and you haven't seen how I built this table or any of these fixture clamps, I'll have a link up above and you guys can check it out. It's a very easy DIY project, and I show you how to build a template and everything so you can lay this table out perfectly. And because this material is just a little bit thicker, we're going to go up just a little bit more on the amperage. So we'll go 140, 18.3 volts. When you're using flux core wire, guys, you want the wire, the contact tip to work distance, to be about 5/8 to 3/4 of an inch. You don't hold it as tight as you would when you're using solid wire. You want a little more stick out when you're using self-shielded or flux core wire. And you can see how that did not stick to that copper bar. And it's flush on the back. Now, another way, a third way that we can use it is to actually repair threads like I was just telling you about in an actual part. And I actually did that on a previous video, and I'm going to show you that right now. It's an actual repair that we did about a year ago on a motorcycle part. Here it is.
You see this bolt right here? Well, that's like a 4mm screw down under the side there. It's all stripped out, so this fairing gets all loose and it wobbles. So this could be a repair to just about any type of stripped out screw hole. I can't go up a size on this, so I have to actually make this 4mm again. Can you see how it should have threads down in there, but it doesn't? So what I'm going to do is I'm going to drill this out just a little bit larger. That way it'll get rid of all that rust and any of the bad metal. Then I'll grind back a little bit around this, and then we'll TIG weld this right shut. The hole will be closed right off. Then once the hole's shut, then we'll just drill a hole through it and tap it. What I'll start doing is take a couple quick measurements from like edge to center and edge to center. That way, once we get this ground back, we know that we get our hole right back in the same place. Now we're just going to wipe down our area with some acetone real quick. Wipe your rod down. Same thing. We've got our hole all prepped. Looks nice and neat. It's clean. Now we've got to start welding. You've got to be real clean when you're TIG welding. I had to turn on my homemade fume extractor. If you haven't seen how I made that, I'll put a link up above. You guys can check it out. But here's the repair. All I did is just wet the base metal just a little bit and just start metering rod. If you guys learning to TIG weld and stuff, just drill a hole in some plate steel and just work on wetting the base metal. So just put your torch on it until the base metal starts to wet, and then just start metering your rod just a little bit at a time until the hole is completely shut. And that's what I've done here. Now I'm going to drill it out with a small pilot bit. And then I'm going to progressively increase the size until I'm at the right size that we need to be at. There. Now I'm just going to chamfer the inlet, and then we'll just run the tap down through it again. That'll help when you go to put the bolt in. It'll help kind of like line it into the threads. Just a little tapered rig here. Yeah, run her down through one more time. There, just like that. We are back in business. Give you a little hint on touching this up. Go raid your wife's fingernail polish. See if she's got some black polish. Black fingernail polish works perfect on doing touch-up stuff like this on frames. It's real durable, so works real good. Just don't let your wife see how good of a job you can do. Then she's going to want you to paint her toes. And there it is, has a nice durable hard shell finish when it dries.
And that's all there is to it, guys. Now, it's not an application that we use all the time, but it's just good knowledge to have, to know that you have some options if you're trying to accomplish something. putting together body panels, fixing a hole that you maybe misdrilled by accident, or fixing a stripped out hole that you need to tap and rethread. If you're wondering what I'm working on, guys, you can check me out on Facebook and on Instagram. And if you're wondering about any of the tools that you see me using, including this welding machine, I'll have links down in the video description. And I've actually got some promo codes that I can share with you guys for this Yes Welder machine, which is going to get you a little bit of money off at checkout. New videos every Friday, so please like, comment, and subscribe. Until next week, guys, I will see you then. Take care, stay safe, see ya. Like, comment, subscribe. Bye.